Welcome fellow learners. In the last video, we have learnt about AI assistant tools or sometimes called as AI super agents or AI agents. We have seen how Octopus V2 model, an on-device LLM, can be utilized to implement these AI assistant tools on edge devices like Android mobile or iOS mobile. So in this video, we are going to implement this Octopus V2 model on our laptop. So let's get started. For this Octopus V2 model, we will use this Hugging Face library that Nexa AI has released recently. We are going to utilize this model as this model is around of size 4.95 GB. We are going to implement this is in our laptop. So basically, the model that can be run on edge devices was not provided by Octopus V2 or Nexa AI. So we are going to implement this model and showcase what the functionality that Octopus V2 is providing us. So first we will import few libraries like torch and OS. We will import warnings to suppress few warnings and ignore them. We are going to see if the GPU is available so that our model can be run on GPU for better performance. Then we are going to initialize this Octopus V2 model. We will use auto tokenizer from transformers to first initialize the tokenizers. Then we are going to use auto model for casual LM to import this Octopus V2 model from Nexa AI. So we will use these two basically libraries from transformers. After this, we are going to use this run octopus function. In this function, this particular line of code is being used to take input text as an input, which will be the user's query, and pass it to the octopus model over here and generate output. Then after generating the output, we will use that same tokenizer that we have seen earlier and decode the output over here. After this, as I have told you in the last video, they have used functional tokens. So they have mapped the output functional tokens to few functions in the output. So like I have used two functions over here only to showcase it. So they have basically created 20 different functions. Out of this, I have used only two functions. So one is get weather forecast, another is set volume. So they have used a Nexa 2 functional token to map it with get weather forecast and Nexa 13 to map it with set volume function. So I have further post processed it and extracted the function name and the argument from it. For an example, I have asked a simple question: how's weather in Mumbai? So if you see, the answer would be something like this. So this Nexa 2 will be the functional token and the Mumbai will be the parameter. And with the help of this, we can directly map our function get weather forecast to it and then extract the parameter also which will be passed to it. Now we are having our function name and the argument that we can get from it. This is the kind of output that we can get from the Octopus V2 model. If you see, at last I have printed this also function name and the parameter name. Apart from this, as I have told, we are going one level up. We are going to also introduce speech to text model over here. So we will not just enter the text directly. We will record our audio and then implement speech to text and then pass that text to Octopus V2 model. So for this speech to text model, we are going to use this Meta seamless M40 medium model. I will share this link also. So you can get this model from this Hugging Face page. Then we will use this two things, processor and the model. Processor is used for processing the audio, and the model is basically to generating the output from this model. So I have basically implemented this speech to text model, speech to text function. Here we will get the file path of the audio that we will be recording, and then pass it to torchaudio.load. So this will load the audio. Then we are going to use the resample method to sample the audio, and then finally using this processor that we have imported over here to process this audio such that it can be given as input to this model in a format that this model requires. Once we input this audio, processed audio to this model, we will get the output tokens, and then again we will use the processor to decode this output over here, and then we get the generated speech to text output from this. So next we are going to implement two functions so that we can use function calling. One is set volume function, another is get weather forecast function. We are going to use ADB cell, which is basically Android debug bridge, so that we can get access to Linux of the Android device and then basically run these commands. So if you see in the first function set volume, if the user has asked to make the volume down, we are going to use this do ADB cell input key event key code volume down. And if we need to increase the volume, we are going to use key code volume up. These will run on Android emulator. I will start that emulator in a while. Another function that we are going to implement is weather function. We have seen this earlier also. So we are going to implement this function also, get weather forecast. And we are going to use the same ADB cell command. And this time we are going to use an intent in the Android device, which will basically search in Google search engine if for the particular parameter that is being passed to this function, as we have seen Mumbai earlier, and basically we will ask for weather of that particular place. These two functions we have implemented. After this run SDB function is used to run this on emulator. So let's first start the emulator. So for starting the emulator, you can use this VS Code, and you can basically install an extension which I will show you. So for the emulator, you can search for the emulator over here and get this Android iOS emulator. You can install this, and after this you can do Ctrl+Shift+P, and over here you can search for emulator, press enter, and press the installed Android devices. You need to install this Pixel XL API 30. I have installed this. You can install any other Android emulators also. So I will run this. It will take a little while to open this Android emulator. Meanwhile, we will go back to our code. After implementing this function, we are going to use a little code for the Gradio UI, so that we can use Gradio UI to record our audio. For this, I will share this code in the description also. So like we are going to use only three things. One is audio box, audio where we are going to record our audio using microphone. There are two buttons. One is submit and another one is clear button. Submit is, both are basically self-explanatory. We have implemented this user function so that first speech to text will be done. So whenever we record audio, pass that audio file to this speech to text function. It will convert speech into text and then pass that text message to our Octopus V2 model. It will provide us the function name and the argument. Over here we have used only two functions, get weather forecast and set volume. We will utilize those function name and the parameter that it has generated, and then pass that parameter to this run SDB function that we have seen earlier. After this, it will run these function in Android emulator using our own ADB cell that we have seen earlier. So this is the a small UI that we have created. Now we can see this is the basically emulator that has been created over here. We will just close it so that it can run on fresh. So let's start this. Let's test how it performs. So first I will record my audio. So I will ask simple question: how is the weather in Mumbai? How is the weather in Mumbai? We can listen to it also. How's the weather in Mumbai? Now, when I press this submit button, it will go back to this user function and run all these function and get us the output. So let's press this submit button. It will take a while, so we will fast forward this video and get to you after some time, because this will take a while, because it will first run speech to text and then run Octopus v2 model, and we are running on very small GPU, and also this model size is 4.95 for this Octopus v2 model, and around 4 GB for also that our speech to text model. So let's wait a while and see the result. So you can see this is now running. This is, you can see the intent has run, and it has searched on Google search engine also. It has searched for weather of Mumbai, as we have seen, as we have asked to it. Now we can see the result over here. So it's quite fascinating how these LLMs can be utilized as AI agents. So it's a great work by Nexa AI to produce this Octopus v2 model. They have recently released Octopus v3 and v4 models also. So like Octopus v3 is even half the size of the Octopus v2 model. So it can have better latency than Octopus v2 model. So it's really interesting to see these LLM work day by day and getting better and better. We have seen a lot of implementation in this video. We have used speech to text, then Octopus v2 model to get functional tokens from Octopus v2 model and map those functional tokens to different functions like get weather forecast, and then using ADB, Android Debug Bridge, to access the Linux of Android Emulator, and then accessing the Android device and doing some commands on this, and then finally getting the results by calling the intent on Android. We have called this intent to search in the Google search engine and get the results from it. It's really good. We will continue working on latest things in language models like these Octopus v2, Llama 3, and so on. We will also introduce and release few videos more on LangChain, how the LangChain works, and different things you will see in following days. So thanks for making till the end of this video. Goodbye until the next time.